We're now shifting gears a fraction from what we've been talking about earlier this morning to a subject that I know journalists, people like me, have been talking breathlessly about for 3 or 4 years. So breathlessly, in fact, the subject of 3D printing, that we kind of ran out of breath. And then we looked around us and we thought, hang on, the world hasn't yet changed. What's going on? I thought this was a revolution that we were never going to recognize ourselves again. The revolution is still underway. I'm reliably informed, and we're going to hear a lot more about that right now from Shane Wall. He is currently the Chief Technical Officer for Printing and Personal Systems at Hewlett-Packard, but is about to become the CTO in general of the company from next month. So congratulations to you for that job.
Thank you. Looking forward to
the raise. And now we're going to find out more about the image of blended reality, what Shane describes as blended reality, how this new ecosystem of 3D printing is going to change the world we live in, from the level of consumer all the way to the highest industrial applications.
Yeah.
Shane, blended reality.
Yeah, thank you very much. So maybe a little bit of context, as Ed mentioned, right, we'll become CTO for HP, and we're going through a major transformation currently where we're actually splitting into 2 companies, 2 $55 billion companies, to become more nimble. And believe it, it's a big difference when you're a little bit smaller than the 110. But with that change comes the chance to reinvigorate and really focus on a lot of what we've been investing in HP labs on printing and personal systems for the last several years. And in particular, that is going after a vision with full intent called blended reality. And very simply, blended reality is that blending of our physical world with our digital world. And we see it today all around us. There are kind of 5 big areas that we're really pushing at HP and that we're pushing in HP labs. They include things like Internet of Things, where we're watching, well, even some of the stuff we saw this morning, but we're watching things like agriculture, medicine, manufacturing, all being transformed, where we're taking physical measurements and we're connecting up the physical environment, operating in the digital domain, and transforming it back. And so we see that in areas like Internet of Things. We see it in mobility, where we move from those glass slabs, tablets, phablets, phones that we stare at 137 times a day, into on our body. And they start measuring all sorts of interesting information about us, and we can take that, transform it, operate it in the digital domain, and put it back. There again, blending that physical and the digital domain. And we see it in other areas like smart machines, where the blending of physical machines back or mechanical machines back with physical beings here. But probably the most transformational, and the one that you mentioned, is in the area that we call 3D transformation. And quite simply, it is we believe, is the next industrial revolution. And we mean it in that full sense. And maybe to put a little bit of context in it, for the last 150 years, we've all lived within the current industrial revolution. Very simple. We make products, and everything that's made is made in the same basic way. You stage in raw materials in some form, just in time. You use automated manufacturing or low-cost manufacturing in order to do it in an efficient way. And then on the back end, you stage it in distribution centers, retail stores, and the like. And then you optimize that chain, and he who can optimize that chain best with some great marketing and financial management wins. And it didn't matter whether you were doing tablets, phablets, phones. That was the vision. And that will be turned on its head over the next 30 years. This is not something I think is going to happen overnight. It's not going to happen in the short term. You see little steps now. But over the next 30 years, you're going to watch that radically change. And we're going to move to a model where we democratize design and we make it much simpler for people to design the products that they want. And then we're going to have them instantly printed, and you'll have them available to you instantly.
Let's drill down momentarily then into the first maybe 3 or 5 of those 30 years and where we're at now already, where 3D printing is now already making a significant impact in industrial design.
Yeah. So today, if you look at 3D, well, first you want to look at the front end, you want to look at the back end. Let's start with the back end. If you look at the back end today, lots of hype for the last 3 to 5 years around 3D printing. And fundamentally, that's shown up mainly in the press in consumer sort of ways. And to be honest, if you look at that total market, that's a tiny % of the market that is actually being served by 3D print. And it tends to be served by probably the lowest part qualities available. But in today, in terms of 3D printing, there are 2 basic technologies available, right? There's extruded parts, which is essentially a glue gun on an XY table that's fed by a spool of material. And it produces very low-cost parts, but they tend to be very slow, 12, 15 hours to print a part of any complexity and very simple, low quality. The second major way is what's called sintered lasering, and sintered lasering is similar sort of an idea, but you use a laser in order to track a bed of powder, lay down a bed of powder, track a laser, fuse it, and you can create a part, and then you build it up layer by layer. And the nice thing about that, you get better quality parts. You still suffer from a serial process being slow and limited quality. And what we're going to watch, and we'll see this over the next 3 years to 5 years, is we're going to see a transformation in that. And at HP, we believe one way that'll happen is through a technology we call multi-jet fusion. And multi-jet fusion we invented and announced it was the end of last year. And it totally revolutionizes how you do 3D printing. It will do it at least 10 times faster than any other process. It'll do it at 20% of the cost, and it will do it with significantly extended sort of materials. And I brought a few parts maybe to give an example of some of the things going on. With multi-jet fusion, we can do all sorts of things. So we can control things at the voxel level. And a voxel is merely, a voxel is a 3D pixel. You can define something in a 3D space. You can define all of the properties of that. It can be color. It could be part quality. It could be, material flexibility, conductivity. We can print electronics. So you can define all sorts of materials that go into a voxel. And then with voxel printing, then you can take things, like a simple matrix here that's done with an elastomer, printed in an elastomer, and can be printed in complete, color.
Those are interesting. You can kind of have a squeeze of this later.
Yes. Or you can do, full color parts, like, here's a simple, it's actually functional guitar that was printed in multiple colors here on multi-jet.
With strings?
With strings on it, right? But what's interesting about this part, not only is it a different color, but it has rigid part on one end, and then it has flexible on the other. So now I can build in different part qualities based on the part I'm building. And in a single part, rather than trying to assemble them, I can now build in various functionality. And you can imagine, which we've already proven we can do and demonstrated and shown, is we can print electronics in here. So we can print conductors, primitive transistors and things like this. So now you can actually print the electronics right into the parts themselves.
I love this one. This is a chain. This just looks like a standard part to a big chain, right? But the point about this, you were telling me, is not just that it's a nice plastic piece of chain, but that this is actually a stronger, more robust, resilient, better structured piece of plastic than has ever been made before?
Correct. Well, that is made in typical, plastic extrusion parts here. So what this is a, plastic part. We printed it with multi-jet fusion. And the advantage of that is with multi-jet fusion is I can lay down on a 21 micron resolution per voxel. I can lay down and control the material properties of that part. And that means I can then control all of the strengths of the material itself and make it extremely rigid. So what's unique about this, it's simple little chain link, is this plastic chain link was used to lift a car. And you can take a look at it on YouTube. You see the actual car we lifted. And you essentially attach a reel chain on this side and the car on a plank on this side and can lift it up. And that's something you wouldn't be able to do with a typical plastic part that things like multi-jet fusion and 3D printing enable.
Because in the past, essentially, any normal piece of plastic would have had impurities in it. There would be points at which it cooled at different speeds, right? And
That's
that would
exactly
create
right.
the vulnerabilities that would cause it to be weak and breakable.
Correct. That's exactly right.
And you have, I mean, you also have a moving part there in a camera and a kind of shutter device.
So this is a simple lens, right, that you can print. And this is all printed as a single print job. And it's a mechanical lens that can open and close, right? So now you have the ability to print things that, are completely functional parts. So this gives you an example of some of the things. We'll introduce the first multi-jet fusion next year, as previously announced. And then you'll
retailing
watch.
at roughly what kind of price?
So this is very important, right? Is we believe where the market is, and the first opportunity is really much more in commercial, real production. And that the initial models that we'll see that really take off are more of printers in a large warehouse where you'll send print jobs to. So they're not going to be these $500 at-home printers. These are going to be $100,000 or more printers that will be have multiple jobs that can come to them all at once.
There is a risk here, I guess, and I guess this is one of the archetypal questions around 3D printing generally, that you, HP, are about to become the Napster of industrial production, right? I mean, where does patent end up with all of this stuff? Anything can be duplicated.
Yeah, so we have an explicit intent not to do that direction. One of my roles in the new company is to run HP Labs, and we have one of our core labs is a security lab, and all it focuses on is security in our core compute products, but it also includes security in our printer and 3D parts. And so there we're doing all sorts of interesting research that can take things like a watermark in a 2D printed image today, which is very common to track images and whether it was yours or you belong to it. We can take those sorts of watermarks and turn them into 3D. And we can now do 3D sort of watermarks that are embedded in part to now actually track a part. So when you can combine that with online being able to track diagrams and digital representations, match it back with physical parts, now you have a way where you can start building in security issues in that chain. It's a huge problem that the industry certainly is going to have to go address. Not one that's going to get solved in the next 1 to 2 years, but I do think it'll be very key going forward.
You mentioned self-assembling. I don't know. I'm going to leave that to you. Explain this, because this is a dream for anybody who has ever shopped in IKEA. Over to you, Shane.
Yeah, so we've talked mainly about kind of what's coming here in the next 3 or 4 years or 5 years, but when you start looking in the future, in that 5+ years, we actually believe in a vision around what we call 4D printing. And 4D printing obviously adds another dimension, but in this case it's self-assembly. And so now it's the idea you can actually print a part, and the part can have different characteristics at the boundaries of the part, and then those boundary parts can be activated. Air, other sorts of nitrogen, things like this, or water, other chemicals, and essentially can activate the part and self-assembly. So to the IKEA reference, you can imagine you buy the table at IKEA, instead of coming home and being frustrated that you had to get it all assembled, you add water, and the table assembles itself. Now, we have some of that going on today, where we actually can take smaller parts, and through simple activation mechanisms, you can show how you can fold them. They'll be self-folding. So those are some of the things coming in that 5+ time frame. But maybe talking about some of the way we see the industry will be transformed, we'll take a couple examples that people probably don't really know. One of them is today with 3D printed parts in a sintered laser situation. You have 3D printed parts being printed in airplanes. And the airplanes that many of you probably flew here on, many of them probably have 3D printed parts already embedded in them. And the reason is you can start building in much stronger materials that can be lighter, because you can do designs you couldn't have done before. So back on our story of Industrial Revolution, you can see these little footprints now, where you watch airlines being changed. You're going to watch things like automotive industry, rather than having to carry parts. So you build a car and you got to have 10 years of parts on hand. Print the part, right? So you no longer have inventory in the parts themselves. You print it on demand and you replace it. And then ultimately, I think you're going to move to where you're going to have subsystems that can actually be printed and either print in the material itself, different characteristic, self-assembled, or much simpler manufacturing in order to put them together.
Okay, people, there is a microphone, as you know, in the middle. We have about 10 minutes left on this. If anybody wants to ask questions, gather yourselves there in the middle, if you will, and fire them out to us. Presumably, you could imagine a situation not far from now where people would be buying, I don't know, an encrypted code from some retailer, and then you would literally just buy the code and stick it into your machine. It would create that patented product for you at home without you having to go to the store or it to be delivered. In other words, that would be a way, perhaps a shortcut way to deliver some kind of retail experience that would work both for the creating manufacturer and for the consumer. Yeah,
and you see little bits of that that are going on today, where you see sites like a Shapeways, right? And in the case of a Shapeways, you can go online. People can submit 3D design parts. You can find those design parts on there. You can buy them, and then they will be printed out and sent to you instantly. And there's probably half a dozen of these stores that are going to be like that. For that matter, even Amazon has a small store where they're starting to do very simple consumer parts, along these lines. So that will definitely happen. You'll move from, you used to go to the store and buy it at the store, and hopefully they had it in stock and in your color and your size, and you had to drive there and you come back. You're gonna, move into a world where you sit, on your couch with your mobile device, and you pick the design you want from a store You edit, change it, colorize it, personalize it, make it yours, and hit print, and it shows up.
Ty.
Question for you. The FAA parts are actually interesting for aircraft parts. However, typically they have to be rated and certified and tested and have to have specific materials and a history of where that part was. How do you plan, and that's an example of a type of part, how do you plan to have certification of parts that have been 3D printed, and what process and quality controls have you been thinking through?
Yeah, so I think it's a very good point, and it's really an extension of some of the IP pieces, right? You could say the intellectual property about whether it's my part or not, but you can also embed in that information about the part itself. So the type of material you use, the quality of the material. Now, by printing the part, you're not going to substitute for many of the other things that go on from a regulatory environment in terms of whether that part meets the specifications required. You're still going to be subject to all of those regulatory issues to ensure that the quality of the part was as stated. But you hit, and I can maybe even expand onto it in a broader scope, is that it's not only the things like whether I followed the certification of that or not, but it is everything about the impact overall to society that's going to go on in this case. So how does it change regulatory processes to know? How do those evolve? How does it change intellectual property rights, to our discussions earlier? How does it change socioeconomic things when the part, our typical industrial revolution, the part maybe is manufactured in a low-cost environment? Well, when that's no longer, really a requirement, you don't need to do that. What happens in societal shifts? And you can manufacture it, wherever you are. So, I mean, there's a lot of things that are going to, over the next, and it is a 30-year vision, over the next 30 years, you're going to watch evolve, or going to have to be fundamentally created.
I'm just curious what your view is on, are there still sort of fundamental technologies in 3D printing in terms of the types of materials or shapes or processes that you feel like are stubborn nuts to crack, you just haven't quite figured out the breakthrough yet? Or at this point, are you mostly onto the, how do we scale it up and build an ecosystem around it? So, where are we in that ecosystem?
Oh, I think it's a combination. So, I mean, from a material standpoint, it gets better and better every day. So, I mean, we obviously have all sorts of plastics that moves to elastomers. We've proven out ceramics. And now metals has been coming in of all sorts. So I think you're going to watch that continue to expand. But I think there'll be a lot of more interesting ones, things like how do I combine those materials, right? That are some tough nuts to crack. Is if I showed you a simple example here, which is I'm merely taking different types of plastic to combine them, but how do you do it if you're trying to combine metal with a different type of plastic or polymer, right? Some of those material things, I think there's still a lot of progress that's going to be made over the next several years.
I guess one way of asking is, what existing manufacturing stuff do you think will be kind of the last to go 3D? You can see which are some of the first, but where do you see the holdouts being?
Yeah, yeah, that's a very good question. I mean, I think we're a long ways from very advanced electronics going in that case. I mean, I can do simple electronics, but the ability to do very complex, highly dense chips, I think that's not in any foreseeable future, right? So I think there. I think I used to say in the drug area or even in the food area, though even in those I'm now starting to think that's probably closer than we think. We'll see what will happen.
There are a couple of guys behind you. I'd like to get as many in as I can. Yes, sir.
This is somewhat related to the first question, but first of all, I think the technology is already world-changing, and you've talked little about the implications for medicine and pharmaceutics. But my question really deals with the underhanded use of the technology to, in effect, impact IP, substitute original parts with parts that perhaps don't meet specification. Do you see the day coming when it would be traceable back to an original printer?
Yeah, that actually, so I'll back up and say, I think you're hitting on the nature of a lot of these societal changes that we're going to go through, because they will, these things will get used for all sorts of, illicit or illegal activity. I mean, we're already seeing it where people are printing guns today, which are fairly easy to do, and you can imagine them printing all sorts of other things, including, fake drugs, for example. But to your point, can you trace it back to a printer? The answer is yes. I mentioned the security lab that we have. And one set of technology around kind of a 3D watermark. But there's another set of technology that we've developed that essentially allows you to analyze a part, and I can tell you exactly what printer that came from, because every part will have a unique signature. And so I can tell you whether that was an original part, I can tell you who owned the part, and I can tell you what printer it came off of. Now, the technology's there. There's a huge thing that's going to have to go on in the ecosystem itself to make that real.
Licensing of printers themselves.
Well, there will
registered
be, right?
owners.
So in some instances, certainly probably for drug use or other instances, there probably will be.
Yes, sir.
Projecting this out makes me think about the raw materials that are feeding the printers and what the economic and business consequences of that are, like the new version of rare earths or whatever is going to become hot.
Yeah, and you're still, it's a good point. I'll give you a negative and a positive, right? I mean, the negative is we're not going to eliminate things like rare earth materials or other dangerous materials that could be used in the process itself. And I imagine you'll watch a set of regulatory things develop in that space. That's on the negative. I will tell you on the positive side that I'm actually very encouraged, very happy about, is what we're doing from an HP standpoint in this space on materials is very different than what we have done in the printer side. Okay? In this case, what we're doing is we actually are creating an open platform. And the open platform will allow other people to add materials in so that we can accelerate innovation in that 3D space. Now, we're still going to have to do things like regulate the materials themselves, but it's no longer going to be driven by a pace of what we could come out with. It will hopefully be driven by what material scientists can come up with.
Squeeze in one last question. Yes, sir.
Are you looking at biocompatible types of materials? So being able to print out artificial knees, hips, kidneys, et cetera, that are compatible with human tissue?
So we are not directly, but some of the technologies that we have developed, both in the 2D domain, which turn out to be applicable back into the 3D domain, as well as to my comment about an open platform, we absolutely are going to enable that from a bio standpoint. In fact, we've proven out, and I think you've seen some of the announcements of being able to print out, actual cells in different structures. So, but that's other people using our technology to do it. It's not us doing it.
An extraordinarily brave new world. Shane Wall of HP, thank you very much indeed. Our time is up.
Thank you.
Thank you for joining us.